All right, we're looking at 13.2. We are graphing trig functions, and we're going to look at amplitude and how that affects our sine and cosine functions. So like I said yesterday, we are going to be graphing sine and cosine functions, and we're going to start adding different transformations. So today we are adding amplitude. So if we look at this equation up at the top here, we have y equals sine of x. We could also incorporate a times cosine of x as well. And a is going to be our amplitude. We're multiplying by a value, so we're either essentially stretching our graph or compressing our graph. We're making it skinnier or wider. So a is going to be our amplitude, where it is our highest point, and negative a is going to be our lowest point, how far away we are from our midpoint. So in our standard graph, we are 1 above, 1 below. So we can see that here where we have sine of x in the black, and it's 1 above, 1 below, our midline, and our midline here at our axis, because we haven't shifted up or down. But this new graph here, 2 sine of x, is 1, 2 above, and 2 below. So our amplitude here, 2, is how far away we are from the midline, what we're multiplying by. What also goes along with amplitude is if it's positive, it's just our standard graph and we're stretching or compressing. If it's negative, however, it's a reflection over the x-axis. So we can see here in black we have sine of x, and then if we have negative sine of x, it flips it over our x-axis. So where we have our midline here, all of our values are flipped over the x-axis. So where we have 91, it becomes 90, negative 1. And then where we have 270, negative 1, it becomes positive 1. So it flips over the x-axis. So let's look at our first example here. Graph y equals 3 times cosine of x. So anytime that you graph, you could always graph the parent function and then move those points. However, our graph's going to get a little messy. So what I'm going to do here is I'm going to draw a table of our x and y values for our cosine graph. So say for cosine of x. So for cosine of x, we're going to be at 0, 90, 180, 270, and back to 360. So remember, cosine of x always starts above our midline, and it starts at 1. And then we keep switching between all our values. So 1, 0, negative 1, 0, back to 1. So this is our original cosine function, and we could draw this, and then we could shift from there. However, what this 3 is doing is it's saying instead of going between 1 and negative 1, we're going to go between 3 and negative 3. So we're essentially taking all of our y values and multiplying them by 3. So if we were to do this, I'll graph this here in blue, we're always going to label. So if I label this, I have 90 degrees, 180, 270, and 360, and we start at 0. And then I always want to label my x-axis. So here, since I have to go to 3, I'm going to go 1, 2, 3, negative 1, negative 2, negative 3. So now going back to graphing, if I'm taking these y values and multiplying by 3 at 0, I'm taking 1 times 3, which is going to be a 3. 0 times 3 is obviously going to stay at 0. Negative 1 times 3 is going to go down to negative 1. 0 times 3 is 0. And then 1 times 3 is going to bring us back up. Whoops. Bring us back up to 3. because 1 times 3 gives us 3. So we have our cosine graph. So remember, it's not just like straight lines. We have this rounded shape. And this graph continues on forever, so we add our arrows. And this would be 3 times cosine of x. So instead of going between 1 and -1, now we're going between 3 and -3. And it makes our graph stretch to 3 and -3 versus our original standard from 1 to -1. All right, example number 2, graph y equals negative sine of x. So our amplitude is essentially -1 is what we're multiplying by. So if we look at sine of x, I'm going 0, 90, 180, 270, 360. And as we get good, we may not have to create this chart anymore, but it's always good to start just to make sure that we know where these values are. So sine starts at 0, and then it alternates 0, 1, 0, -1, going back to 0. So we're essentially flipping it. So we're multiplying by -1. So I'm going to take all my y values and multiply by -1. So if I go ahead and graph this after I label, so if I label, I have 90, 180, 270, 360. We could always have different scales, and as we get further, and we're going to see that we're going to change our scales, so we always want to make sure to label. So here, you can really put 1 anywhere as long as you're labeling, and we know that you're going between these values. So we'll say we'll put 1 here and -1 here. So if I'm graphing, I start at 0 because we're multiplying. 0 is going to stay 0. Now 91 is going to go from 1 and reflect over the x-axis down to -1. 180 is going to stay at 0. 270 goes from -1, flip it because we're multiplying by -1, becomes a +1, and 360 stays at 0. Draw in my shape. I have my sine function. Draw those arrows because remember, it repeats and repeats and goes on forever. All right, for example 3, y equals 1/2 sine of x. I'd like you to try this one on your own. So go ahead and pause the video, graph 1/2 sine of x, and then play to see the answer. Ta-da! We have our y equals 1/2 sine of x. So we took our sine starting at 0 and alternating, bouncing up and down, times 1/2. So biggest thing is your scale. So you may have had yours on the first line. That doesn't matter. The big thing is we know we're going from 0.5 1/2 to -0.5. And we're starting at 0 and ending at 0. And we've got the same shape going on here. Moving on to example 4, we are now going to be given a graph and asked to write an equation. So we talked about that our possible equations right now, based on what we know, is our amplitude times sine of x, or it could possibly be our amplitude times cosine of x. So we have to identify what type of function it is, sine or cosine, and then determine what is our amplitude. So if I look at this graph, what I always want to do is I want to identify where's my midline. So my midline is what cuts through the center of the graph, so it's the same number above and below. And right now, all we know is the axis. We haven't moved up or down yet, so this is going to be my midline. So from here, I can identify sine or cosine. Because it starts on the midline, it starts at 0, this is going to be a sine graph. Because it starts at 0, starts on the midline. Now our amplitude is going to be how far above and below I am, what I'm multiplying by. So if I look here, I'm 1, 2, 3, 4, 5 above the midline. So I took my original starting point here of 1 and multiplied it by 5. So here my amplitude is 5. Now, all we know so far is amplitude goes out in front, so that's all we're focusing on. So our equation would be our amplitude times our trig function of x. So y equals 5 times sine of x. All right, go ahead and try example 5. Identify what type of trig function it is, identify the amplitude, and then go ahead and write an equation based on this graph. Then go ahead and play the video to see if you have the correct answer. All right, hopefully you got y equals 1/2 cosine of x, or if you had 0.5 cosine of x, that is just fine. So if we draw on our midline what cuts our function in half, we see that we start above the midline. Since we start above, this is cosine. And since we're not starting at 1, but rather we've cut it in half, we're multiplying by 0.5. So that means our amplitude here is 1/2 cosine of x. And our last example, example 6, going through the same thing, given this graph, we want to identify what the equation is. So pause the video, try it out, write down your equation, and hit play to check your answer. And we should have y equals negative cosine of x. So if we draw our midline in, we cut this graph directly in half, we can see that we start off our midline. So that means we have a cosine graph here. But cosine usually starts at 1. However, this one is down at -1. So if it starts at a negative value instead of a positive value, that means we have a reflection. So we have negative cosine of x because it's just down at -1. If it was at -2, we would have -2 cosine of x. So now go ahead and try your 13.2 practice worksheet, going through some more examples of amplitude and reflections.